Question 5. We need to use the formulae for the summation of r squared and the summation of r to show that this summation here is equal to 3n times 4n squared take away 1. So in this question, the first thing I want to do is I want to expand the brackets over here so I can write this as separate summations. So I want to first of all start by expanding 6r take away 3 squared. And that's going to be 36r squared take away 18, so take away 36r plus 9. Okay, so to split this summation up now, I can say that I've got n r equals 1 there, and that's going to be 36r squared, so it's going to be 36r squared take away, and we've got 36 of the summation of r plus, and that's just going to be 9n. Okay, so I now need to, because I know the summation of r squared is equal to this over here, I'm going to do 36 times by 1/6 n times n plus 1 times 2n plus 1. So 36 multiplied by this is going to give me 6. So 36 times 1/6 is 6, n times n plus 1 times 2n plus 1. And I'm going to subtract 36 times this, which is half of n times n plus 1, so 36 times by a half is 18, so that's going to be take away 18 times n plus 1 plus 9n. Okay, so next thing I'm going to do is I'm going to have a look at where there's any common factors, and I can see that 3n is a common factor of each of these terms, so I'm going to take 3n out as a factor, and then I'm going to have that's going to be 2 times n plus 1 times 2n plus 1 take away, and that's going to be 6 times n plus 1, and that's just going to be plus 3. Okay, so I've taken 3n out as a factor. Okay, so I'm going to leave this part here in factorized form, and I'm just going to tidy this bit up over here. So I've got equals 3n, and I've got 2 times n plus 1 times 2n plus 1, and that's going to be subtract 6n take away 6, so it's going to be 6n, and then subtract 6 but plus 3, so that's going to be subtract 3, subtract 6 and then plus 3. Okay, and now this part here is going to factorize, so let's do another line. 2 times n plus 1 times 2n plus 1, and here I'm going to subtract, and a common factor here is 3, and that's going to be 2n, so that will give me the subtract 6n bit, and plus 1, which will give me the subtract 3 bit. Okay, now what you might notice here is that I've got another common factor here, because 2n plus 1 is a factor of this term and this term here, so I can bring it outside of my square bracket. So I've got equals 3n times 2n plus 1, and then inside my brackets now I've got 2 times n plus 1 take away 3. Okay, and that bit here, if I okay, we'll do it on a separate line. Okay, so we've got equals 3n times 2n plus 1, and then this bit here is going to be 2n plus 2, but I'm then going to be taking away 1, so 2n plus 2, 2n plus 2 take away 3, which gives me 2n take away 1. Okay, so that's writing it as 3 linear factors, but I've just noticed I want to write it in this form here. Well, 2n plus 1 times 2n minus 1 is in fact just going to be 4n squared take away 1. So I can say, well, that's going to be equal to 3n times 4n squared take away 1. Okay, and if I would have noticed that before, I could have just expanded it out there. But oh well, we've got the answer now. Okay, so that should give me my 5 marks there. Now, part B says, hence express this summation. So I've got r to 2n of r cubed, take away the summation that I've already calculated as a product of 4 linear factors in terms of n. So I'm just going to tidy up this part of my working. Okay, so dealing with this part first, I've got the summation of r cubed. So let's do this in a different colour actually, so we'll go for part B over here. Oops. Part B over here, right, so the summation of r cubed, and this is the formula that I'm going to use over here. So that's going to be a quarter of n squared, but I've got 2n over here, so that's going to be 2n squared, and then I'm going to times that by n plus 1 all squared, but because that's 2n, it's going to be 2n plus 1 all squared. I'm then going to subtract 3n times 4n squared take away 1. I'm going to write this as 2n plus 1 times 2n minus 1. Okay, now I can see from here that I can take a quarter. So let's expand this part here. So I've got a quarter times 2n all squared. So 2n all squared is going to be 4n squared. And if I do a quarter of that, that's just going to give me n squared. So that's going to be equal to that part there, which simplifies to n squared, times 2n plus 1 squared, take away 3n times 2n plus 1 times 2n, take away 1. Okay, and I can see that n is a common factor for both of these, and 2n plus 1 is a common factor for both of these. So that's going to be equal to n times 2n plus 1, which I can take out as a factor. And then inside my brackets, I'm going to still have an n times a 2n plus 1. And I'm going to have a subtract 3 times 2n minus 1. Okay, so I'm now going to expand what's inside these brackets because I can't see any of the factors that I can take out of it, so I'm going to expand it. So that's going to be n times 2n plus 1, and then inside my square brackets here, this part here, I'm going to have 2n squared plus n, take away 6n, take away 6n, and plus 3. So that's going to be, and I'm just going to come over here, that's going to be equal to n times 2n plus 1, and then here I'm going to have 2n squared take away 5n plus 3. Okay, so that's going to be equal to n times 2n plus 1, and I want to factorise this quadratic expression here. So if I factorise that, I'm going to have 2n, that's going to be n, and I need the product to be positive 3, and so I think I need negative 1 here, and negative 3 here. Let's just check that that works. So I've got 2n squared, take away 2n, take away 3n, which gives me take away 5n, plus 3. And now that's 1, 2, 3, 4 linear factors. We've managed to write this as the product of 4 linear factors. Okay, I hope that was useful. Thanks very much for joining me. I'll see you next time.